Thank you. Hello, everyone. Welcome to our first meetup for the year 2022. I'm your host, Afnan, and working behind the scenes are my team members. Is it working? Yasmin, Hassan, Shada, and Abdelilah. Shada will be handling the questions later on. But first, we would like to welcome our host for this meetup, Omar Sanseviero. We will learn how to build machine learning demos and portfolios with Python. Omar is a machine learning engineer with 7 years of experience. Currently, he is working at Hugging Face in the open source team, democratizing the usage of machine learning. Omar previously worked at Google as a software engineer in the Assistant and TensorFlow graphics teams. He's also passionate about education and co-founded AI Liares, a Spanish-speaking community of people that want to learn about AI and its different applications. Thank you, Omar, for joining us. And also we want to thank our sponsors, Numfocus and Muzun. Finally, you can find us on Twitter and at PyDataJiddah to be updated on upcoming meetups. And also you can find all previous meetups on pydatajiddah.com. And that's it. Thank you. I'll stop sharing so you can share your screen, Omar.
Awesome. Thank you very much for that introduction. 1 second, sharing my screen. There you go. Can you see my screen correctly?
Yes, great. We can see it.
Perfect. Yeah, so thanks for the intro again. So hi everyone, I'm Omar, and as they mentioned before, I'm going to present about how to build ML demos using Python. Very quick, brief intro about me. I'm from Peru originally. I live currently in Switzerland, as you can probably guess by the flag behind me. I came here to work at Google as a software engineer in the Google Assistant team. I also work part-time in the TensorFlow graphics team. And since about a year ago, I've been working as an ML engineer at Hugging Face. You might not know Hugging Face. I will talk a bit more about it a bit later. But for now, let's dive directly into the topic. So probably like if you've done machine learning before, you face this story. So this story is many times you spend a lot of time training like some very cool, interesting ML models. That might be a research project, that might be a school or university project. It might be some project in your company, and you might spend 1 month, 3 months, half a year, or maybe even more. And then you realize after you already have like this cool model, you don't have any easy way to share the model with the rest of the community. So maybe you can share the model in GitHub, like the code to train the model again. But there is no simple way to, for example, create a demo. So if you want to apply to a job, your potential employers are probably not going to go to your GitHub repo and run this code up that you might have linked in your page, right? What you probably want to do is give them like some interactive demo that you want to hand them directly. And also, for example, for university, it can also be like extremely useful if you just want to share the demo and not like the whole code for people to run every cell of a Jupyter notebook. And then you realize that if you want to do this, you might need to start learning JavaScript maybe, or like some web technologies, so Flask. And probably if you come from the machine learning ecosystem, many, like I think most people really don't want to do that. So I'm going to talk about something called Hugging Face Spaces. Let me go like a bit through it. So instead of having to learn about Flask and HTML and React, Svelte and JavaScript, you can go directly and use like open source libraries such as Gradio or Streamlit. So you might have heard about Gradio or Streamlit before. They are like very easy to use open source libraries. So let's say that we want to build a demo such as this. So this is a model, sorry, this is a demo in which you translate from English to Spanish. So at the left, the user can write some input, they will click submit, and at the right, there will be like the output, which is the translated text in Spanish. The user can clear the input, they can take screenshots, they can try out like some default examples at the bottom, or they can try out like some new examples. And if you do this, and actually let me just show it to you directly. So this is the demo. as you can see, it's like a public URL, so you can easily share the URL with anyone. And if you go here right now, you can try it out as well. If I try, I like this workshop, and I click submit, after a few seconds, I get like this translation in Spanish. I can take a screenshot, and well, yeah, I'm going to talk a bit more about it, but let me show you two other demos. This one is cool. This one might take a bit longer. Actually, it's giving me an error right now, so I will skip this one. And this one is a story generator, so I put some text in Spanish, and this one might take like 20 seconds or so. It will generate like a nice story in Spanish. So this is saying like the adventure begins with, and after some time it will give like some nice story. Sorry for that. Yeah, so if you see like how to do it, you might be a bit scared, and you might be like wondering like, how can I do it? Like that seems that it might take me half a day, and it really takes like 5 to 10 minutes. So yeah, don't get scared. So this is all the code you need for this first example I showed you. And just as a disclaimer, in this example, I'm using a library called Transformers, which is an open source library by Hugging Face. But really here you can use any library that you like. So if you're a TensorFlow user, a PyTorch user, SpeechBrain, like if you have like any preferred open source library, you can really use anything that you prefer. So let me go a bit line by line by what's important. So at the beginning, I'm just importing Gradio, which is the library that I'm going to use to build this nice interactive interface. Then I'm importing the pipeline function from Transformers. The pipeline pretty much allows you to specify like what task you want to solve. So you can specify things like text classification or translation in this case, or summarization. And then you can specify which model you want to use. In this case, I'm using a model from the Helsinki University. There's an NLP lab, and they have shared about 1,000 models for translation. So this model is translating from English to Spanish. Don't worry too much about this specific code, like the code for transformers. As I was mentioning before, here you can use any ML library that you would like to use. Normally in Gradio, you need to have some specified input and some specified output. So you need to specify like this box, like a predict function that takes some input and has some output. So don't worry too much about what's the exact syntax here, but pretty much I'm receiving some input, some text in this case, and then this depends on your library. In the case of transformers with pipeline, that's the way in which I can get the output translated text. After this, these final 8 lines of code are like everything that is needed for the actual UI. So I have a title, which is Interactive Demo Helsinki NLP, English to Spanish Translation. And everything happens in this interface class or method, actually. So you specify what's the function that will do the processing, the prediction. Just specify what's the input or multiple inputs. So in this case, I want a text box that has text and is 3 lines. And the output in this case is the translation. So that will be a text as well. For the interface, you can also add a title, which is the title that we defined before. And you can specify examples as well, which is what you saw before at the bottom left. People were able to try out some examples. And pretty much that's it. You just do a .launch method, and that will start the interface. And voila, you pretty much have it. So maybe you're wondering, okay, how do I run this? And this actually works in Colab. So this is a Colab notebook. At the top, I'm pretty much just installing Transformers, Gradio, and SentencePiece, which are the libraries that I'm using right now. And this code here is exactly the same as the one I just showed you. So I'm importing Gradio, Transformers, the pipeline. I have here the prediction function that takes an input, which is the text, and has some processing for the output. I have a title, and again, a prediction function, an input, an output, and pretty much that's it, right? So the first time it might take a bit because the first time it needs to load the models and all of that. But after that, you already have here directly in the Colab a cell in which you can try out this demo. So here I try this one. Hello, my name is Omar, or I like this workshop. And here I pretty much already have like some interface. I can take screenshots, which will download a screenshot. So if you want to share that in social media, you can do that. And you even get this link, this link from Gradio. So this is a link that you can share and that will last for 72 hours. I think the first time it might be a bit slow, but it's already kind of useful and it's very nice. Okay, let me continue with this. So under the hood, Gradio is using Svelte and Flask and other libraries that you don't have to bother learning. Gradio is like this very nice high-level open source library that hides under the hood a lot of boilerplate, a lot of web development stuff that you probably don't want to learn. And as you just saw, with only like 10 lines of code, I was able to build this nice demo. So I've been talking about Gradio. You probably have heard about another library called Streamlit. Both are very easy to learn. Actually, I would suggest you to try out both of them because, as I was mentioning, like, it's really, really easy to learn. Gradio is very nice when you want to have an interface in which you have an input and an output, and it's very clear. Streamlit is very nice because you can build like more complex web apps. So you can have dataset visualizations, you can have maps, you can have like very cool stuff. And it has a super nice community. They have a community built components. So for example, if you want to have a molecule visualizations, there's already a component built by the community for this. So actually, I would suggest you to just go to the Streamlit.io website. Again, these are open source libraries, so it's free to use. So you can go to components, for example, and here you can explore components built by the community. So for example, this one is for molecular structures using Streamlit, but here you can search, for example, if you want visualizations, right? So this is for graphs, for example, this is for volume maps, this is for charts, maps, and you can explore all of these components built by the community. They have NLP stuff, they have videos, video tools as well. Yeah, so I would suggest you to take a look at it. And these are community-built components. They also have a bunch of things built by themselves. And they have like this gallery of very nice examples that you can also try out. So yeah, I would really suggest you to try out both libraries. Both are very great. All right, so far we built this nice demo. I have a collab. As you saw, the link expires after 72 hours. And now there's no easy way to share it really, right? So you can share this collab, but after all, the user still needs to execute all of those cells. So what if you want to share it with the community? What if you want to discover these demos built by the rest of the community, right? So at Cogniface, we built Spaces, which is a nice tool in our platform, which allows to share and discover new demos from the community. So this is the website. It's hf.co/spaces. And here pretty much you can explore Gradio and Streamlit demos built by the community. So there are a few hundred, I think like 2,000 maybe, spaces built by the community. And here you can find all kinds of things. And here at the top, you can find like which are the feature demos built this week. So for example, yeah, there are like different things that we can try out in a few minutes. For example, there's a shark classifier demo or an Arabic NLP demo, which right now seems to be broken. Let me take a look at the shark classifier one. And these are not built by us, these are built by the community, which is very nice. For example, here, people can put pictures of sharks, specify which model they want to use. And after a few seconds, they get like what's the name of this specific shark. So it's very nice. So let me show you what happens if we want to share this demo that we just created, right? So what I would do normally is I go to my profile picture, I click new space. specify what's the name, you can specify Streamlit, Gradio, or static. Static is kind of a third choice. So if you do want to use JavaScript, if you want to use HTML and share HTML demos with other people, you can do it as well. You can make it public or private, whatever you prefer. You can do unlimited of any. And after you kick this off, it will give you like some tips. So these are Git-based repositories. That means that you have version control. So for example, going back to the Shark demo, you can go to files and versions. Here I can see like the whole Git history. So if I click history, I can see all 41 commits. This is a Git repository, so I can do Git clone as well and work locally and collaborate with others and do the Git push. So if you've used GitHub before, these are pretty much the same workflows that you are probably used to. So you can do the usual Git clone, Git add, Git commit, Git push. You can even do branches if that's something you want. Going back to the demo we're building right now, it says that you need to create an app.py file, and I can do it locally if I want, but in my case, I would prefer today to do it directly in the browser. So let's create a new file, which is app.py. Let's copy paste the code from the Colab. And I think that's pretty much it. So now you need to build a few seconds while it's building, and probably in this case, it's going to fail. And let me explain it why in a few seconds. So I'm getting runtime error, and it's telling me that it's not finding the module name transformers, right? I could also like go directly to the logs here with this CLogs button if I want to see things, but it's pretty much the same thing. So what's the issue right now? If you recall, in the Colab at the top, I was installing transformers. So here in this environment, which is at the end, some Docker hosted environment, I don't have transformers installed. So I can also specify dependencies. So I can create a new file, which would be requirements. And here I can specify what I want to have. So I want to have transformers and sentence this. And I think I also need PyTorch for this case, which already comes installed in Colab. Now it will take some seconds again, this time because it needs to install these libraries. So if I go to see logs, I can see all the logs that are happening. So this is very nice because this provides me a way to debug everything that's going on right now. This will probably take 1 or 2 minutes. Let's wait a bit. Yeah, so it's already running. Here I got the demo. So interactive demo Helsinki. So this is the same one that I had in Colab, but now this is a link that anyone can access. So I can try it out. And as you can see, it's actually extremely fast, right? It's 0.22 seconds. So it took a bit the first time, but after that first time, it's super fast for anyone to use. People can take screenshots. I can look at files and versions. I can even go to settings. So if you want to add keys, for example, if you have some APIs that you want to call, here you can add those. And then users won't be able to know which are these keys, which are very important. I can make this public. I can transfer this. So yeah, it's very nice. And again, like this is based in Git, so I can look at the history. I can Git clone and work locally as well if that's something I would prefer. So that's what Spaces gives us. And this first use case that we just did, let me show you, is like this, right? So any user can go to the Spaces website, and then they can go to, in this case, I'm using transformers, but you could be using TensorFlow, you could be using PyTorch, you could be using some higher level library if that's something you would prefer. But there are other things you could do. In this case, this might be a bit slow. If it takes like 5 minutes to run a model, it's not very optimal. In the case of transformers models, we have something called the Inference API. So the Inference API is something that all transformer models get out of the box, and it's like a very high-level optimized API that people get access for inference of the models with a normal like HTTP call. If you have not used this in Python before, this is only like a usual like request that you can make. It's also like few lines of code. And this is the code. Again, the code is even easier now because right now I'm only calling the inference for a model. Sorry, so here I'm adding a description, a title, and pretty much I'm saying I want to load this model, which is in Hugging Face, which is called Omar Sanseviero Big Can Div 128. So where is this model? So I could search here for Big Can. So if you have not just Hugging Face has three things. It's a platform in which you can find models, datasets, and demos, which are called spaces. So the model hub allows you to find 25,000 models. It's very cool because you can search models. Let me go this size, yeah. So you can search by task. So for example, if you want to search NLP tasks such as question answering, text classification, translation, conversations for chatbots, you can do that. You can also search for models that are not for NLP. So if you want a model that is able to transcribe the audio to text, or the other way around, if you want to generate artificial synthetic sound out of some text, you can also use that. If you want to do audio classification, you can also do that. So that's another option. And if you want to do computer vision, you can do things such as image classification. So image classification allows you to classify an image, object detection or image segmentation. So you can do pretty much quite a bit of things, but you can also search by library. So the hub has not only transformers models, but also Spacey, adapter transformers, Stanza, Keras, speech brain. So if I go here to Spacey, I see that there are like 150, almost 150 Spacey hosted models. One sec. You can also search for Keras. So for example, Keras has been adding some very nice models recently. So you can go to the Keras.io organization, which we also have. And here are like some examples of some cool Keras-based models that you can find. So that's very nice. You can also, maybe that's of interest to many of you, you can search by language. So for example, I speak Spanish, I would normally go to ES, and I can find that there are like a few hundred Spanish models. So yeah, that's very nice. That's not everything. So for example, once you go to a model, there's something called a model card. Model cards are something that were proposed 2 years ago, and they are pretty much a way in which people can document what a model is, how it was trained, which are the intended uses and limitations. So for example, if there are biases, here is like the perfect place to put those biases and limitations. And also like examples, how to use it, what was the data used to train this model, and then a citation. So it's very nice. And then you get these widgets at the right that you can try out if you want to try out the model directly here in the browser. So that's pretty nice. You can click here using transformers, and here you can find like this super small self-contained 3 lines of code example on how to use this model. Finally, here you get like tags, which are very nice for discoverability. So you can search for English-based models, for example. So yeah, that's very nice. So going back to this API demo that I was telling you about, here I'm using this model which is called BigCan, which is the one I showed you before. This comes from the hub, so this is a model that I was able to find up there, and I can use this model directly, right? So I think that was this one that was failing. So let me just very briefly check why it was failing. And it seems there might be some types issues. Something you can always try if you want is to rebuild this space. So let me just quickly trigger a refresh. So the space now is building again. So you again need to wait a few seconds while things are being installed. Again, I can go to files and versions. And in this case, I again have this app.py file, which again is only like 13 lines of code. So it's nothing complicated. Let me see if it's working again. No, so I'm having like some issues. Some issues with types. I will need to check this afterwards. But yeah, I think you get kind of what's the sense of this. And this third example I wanted to show you which I was showing you before, is this one. So this one, I'm inputting some text in Spanish. I click submit, and I get this larger story again in Spanish. So how does this work? And this is actually like a very cool idea, which is as creating a series of models. So actually, there is no Spanish model to create stories, but there's an English model to do it. So what I can do is translate the text from Spanish to English, run this through a generative model that can generate these stories. And finally, that output I can translate back to Spanish. And actually, it's again quite easy. Don't get intimidated by the amount of code. It really is easy. So I'm loading 3 models. So the first one is a model from Helsinki, again, to translate from Spanish to English. And again, like you can go to the hub and you can find this model. So let me search Helsinki. You can find that it's an organization. It's an organization that has 1,300 models. That's why it was a bit slow. They have quite a bit of models. And here you can find a search for models translating from one language to the other. So if you want from Spanish to English, I would search for yes, Jan. I can see that it has some likes, so I will also give a like to it. I use it quite a bit. It has had 150,000 downloads, and I can try it out directly here as well to check if the model is working correctly. And I can find a bunch of information as well. So it's quite nice. Going back to the code, that was the first model I'm using. The second model I'm using is an English-based model using GPT-2, which is creating a story. And finally, this third model is one that will translate from English back to Spanish. So I can create with Gradio a series of interfaces, so from Spanish to English, then the story generator, which works in English, and finally a translation model. And all of this together will give me like this nice interface that I can use. So yeah, it's very nice. It's quite easy. This one was this demo that I was showing you, right? So you write, the adventure begins with, and then it continues. Like the adventure begins in the year 1980 with it's just a story. And you can go to files, I can go to app.py, and really it's the same thing I just showed you. So I load a Spanish model, then a story generator model, and finally an English to Spanish model. I connect one after the other, and that's pretty much it. So it's very nice, and it works nicely. Before closing, I would like to show you like some nicer, more complex demos than this one. So first, this one from Microsoft, just to show you that it's not only about text. This is a nice example for audio. So this is a voice authentication space in which you can input 2 different audio files, or you can record yourself. So for example, if I try 2 samples from Case Blank and I click submit, it will take a few seconds. We can just wait, and it will tell me that this is the same speaker. So the audio is the same speaker saying different things, but this model was able to identify that this was the same person. Then I can try 2 different persons. So Leonardo DiCaprio with Russell Crowe. Again, these are different audios, different length, and it's telling me that they are only 70% similar, so they are not the same speaker. And it's very cool because I can go to files and versions, I can go to app.py, and I can see all the code to do it. So yeah, it's very nice. It's very nice that people are sharing these kind of things. Let me go to a second one. This is using Streamlit. So as you can see, the interface is quite a bit different. This is a face mask detection model using ResNet. So ResNet is a model for object detection. In this case, what it's doing is identifying if people are using mask, wearing the mask incorrectly, or they don't have any mask. So as you can see in this picture, this guy is not using the image correctly. Few people don't have any mask at all, and these 3 people are using mask. And you can drag and drop here. So it's telling me it's being processed, and finally, like, yeah, you get this output, which is quite fun. It's very nice. And again, you can also try, like if you have local images, you can also try it out. Again, like we can go to the code. Just as before, people have requirements, txt files with the requirements. So it's very nice because it's like an open, collaborative, community-led way of sharing this kind of models. You can go to the app.py. The code here is a bit more of code than before because this demo is a bit more complicated. But even then, like if you saw like everything that there was, it's really quite simple. The code is not complicated at all. You can have in Streamlit things like caching, which is very nice because it makes the demos faster. And yeah, that is like all the inference code. So the conclusion of this is that if you already have a Colab or a Jupyter notebook in which you are expecting people to just run a bunch of cells, you can very easily, like in a few minutes, translate all of that to one of these demos and make something much cooler, more interactive, and more accessible to even people that don't know about machine learning, which is very cool. There's the Jojo example. So here you can put an image and it will translate to different styles. So for example, if you want to try Disney kind of style, sorry, Disney, I can click submit. It will take a few seconds and it will translate, or let's say, do style transfer or stylization for this image to one style of this. So it could be Disney style. So yeah, this is Mona Lisa Disney style. Again, you can like it, you can look at the files, it's very nice. This is another example with images. So this is an echocardiogram segmentation demo, and it identifies the left ventricle in the echocardiogram images. So it's like another way. So yeah, so if you're building a portfolio, this is very nice. If you want to showcase to your clients, so for example, if you work in consulting or if you want to show this to some stakeholders, your managers, these are like very nice interactive way of showing how a model works. So it's like a very nice way of creating prototypes. Let's super quickly go through two other models. This is one that was released 2 weeks ago, I think, from OpenAI. It's called Glide, and it allows you to put some text. So for example, here, an oil painting of a corgi. You click submit, and it will generate one image, which is very nice. So this is an oil painting of a corgi. People can also add like more text below. So for example, here I have a link to the official GitHub repository or to the paper. So yeah, it's very nice. And this final example is from with using the Spaces Library, which is also a NLP library, using Streamlit for ancient Greek. So here pretty much they load this model, Perseus large. They input some Greek text, and then it does a bunch of very cool linguistic stuff. So it identifies this is a noun, this is a verb, or for example, it gives you like some syntax tree that it's interesting. Like so this is a root, this punctuation, things like that, and you'll even get like this table view. In the case of Spaces, very nice. They have like a from the canonical, like official models. They have like a one nice script that allows you to push models directly to the hub. So that's very nice. And they share like 64 official models here. And as a user, I can just click here using Spaces, and I just need to copy paste this, and I already have the model directly in my own computer. This is very powerful because this is about making machine learning accessible to everyone else. So if you have like some cool models, but you expect people to access it through a Google Drive link or a Dropbox link, or if you are hosting it in your own university server that crashes every few weeks, this is a bit more powerful. It's more discoverable as well. In the case of these pipeline visualizers, they are very cool because here you can go, you can select one of these 60 few models. So for example, I can go to the Spanish model. I can wait a bit. Here I have some example text. I can find here the verb, determinant, different kind of stuff. I can get name entity recognition, which is like this is an organization. So Apple is an organization. The UK is a location. You can get things like word similarity. So apple and orange are not that close, but if I try apples, okay, but that is not working like very nice. Oh yeah, because this is in Spanish, right? So which is apple and orange. So that's much better, right? Yeah, that's much better. Yeah, this is pretty much what I wanted to show you today. Again, before closing, I would really suggest you to really check out Streamlit. There are a bunch of very cool resources and demos built by them. I was showing you today Gradio because it's a bit easier to learn, a bit easier to understand, and as you were able to see, it really took like few lines of code to build like some nice interactive demos such as this. Yeah, thank you very much.
Yes, thank you, Omar. We will start with the questions with Shada.
Thank you so much, Omar, for this valuable information. Now it's time for taking questions.
Mm-hmm.
If you have any questions, please free and leave it in the chat box. Okay, the first question is, how can we go through these demos in details later?
Sure, that's a good question. Actually, maybe I did forget to mention a couple of quick things. So the first one is that one cool thing about sharing your demos through Hugging Face Spaces is that all your demos are at the top of your profile. In my case, they have a bunch of demos here, but if you have like some projects that you really want to showcase to, like in your resume, for example, this is a very nice way of building your own kind of a machine learning portfolio. So it's very useful because then you can just share this link to people and they can use it. So if you go to my profile, you can find this. But if you really don't want to check my profile, and that's totally okay, I will share the link as well. I have this code up there. So let me put the link in the chat. Yeah, so you can go to the hackerllama/chartlas, and here I have this notebook which shows you these 3 demos, which I hope it's useful. But again, like the learning curve for Gradio is very nice, very easy. You can always begin with a return hello world, so not using any machine learning. And yeah, it's like very easy to just start building on top of what you've done already.
Okay. How can we customize the interface? Are there any guidelines or standard for interface?
Mm-hmm. Yeah, so that's a good question. So like right now, if I go to the files, what you specify it's what's the type of input and what's the type of output, right? So you can go to the Gradio documentation, for example. And here you have like all the types of components that you can use. So text box, numbers, sliders, checkbox. They have like demos directly in Colab that you can try out. Audio, videos, files, even data frames, if that's something you want to show, or time series, that's also possible. So you can do all of these kind of things. You can even modify the layout. So if you want to use a bit of a HTML and CSS to do like a bit more crazy kind of stuff, you can also modify these things. But apart from that, you have access to all of these things. So you can modify the inputs, outputs, examples. Then there are like even like some cooler stuff. So let me show this one. This one allows me to draw something, and it will search for images from movies for this one. So for example, I'm going to draw a chair. So it found this image which has a chair. So yeah, it's nice. So yeah, it has quite a bit of flexibility, and even then, like if this does not work for you, you can then code a very bit of CSS, like if you have like more custom stuff. So for example, this demo, the one of the 2 audio files, this one does use a bit of a custom HTML and CSS to have like this nicer, like more non-conventional kind of output.
Okay. Are there any limitations, especially in terms of the model size?
Yeah, that's a good question. So as I was mentioning before, we use Git. And if you've used Git before, probably you've faced issues that you cannot upload files larger than 10 megabytes. In the case of Hugging Face, for models, datasets, and spaces, we also use something called Git LFS, which allows to share very large files. So yeah, you can use Git LFS if you need to upload some like larger models. So actually, like if you go to models right now, and I go to GPT-2, like these files are 500 megabytes, right? I can hear 520 megabytes and 475 megabytes. So the files are quite large, but you can use Git LFS. Git LFS is pretty much the same as Git, so you are using Git. But the only thing that you need to do is add Git LFS install, And that's pretty much it. And then if you have like some weird extension, you can go to the Git attributes. And here you can specify like what file extensions you want to be handled directly via Git LFS. Other than that, there are not that many limitations. In the case of spaces, of course, there is a limitation in amount of memory. So we can go to the docs. So there's documentation for spaces here. And yeah, so you get 16 gigabytes of RAM for free. So yeah, there's a bit of a limitation, but usually this works quite well. I would say for 95% of use cases, even a bit more. So yeah.
Okay. Can the output of demos be visual made by Plotly or Matplotlib? For example, plotting a word cloud based on the user input?
Yeah, yes. So in the case of Gradio, for Streamlit, it might be a bit different, but in the case of Gradio, what you can specify is the output, right? So you can say that I want my output to be an image, but something that you can specify is what's the path. So you can output directly the image if you want, or you can specify like what's the path for that image. So what you can do here very easily in the demo is somewhere in the code, you can, let's say, save the file of the visual made by Plotly or Matplotlib, and then you can have the path of that image directly in the output. Or if you do have directly already like the build image class, you can also output that. And actually, like I just saw this, I didn't know, but it already supports Matplotlib pipeline. So you can already output this directly as the output of an image. So this is something that you can definitely do.
The first submit takes longer time, but it's speed up after the first submit. Why? Is it because the model loaded in the memory? One Cardio project will utilize of all GPU memory, right? What if you have a several Cardio projects and want to run all of them in the same GPU? Will it work?
All right. So I think those are kind of two different questions. So let me go first to the first one about why the first click in submit takes longer time. It is not necessarily the truth. So it's the first submit, the first time after building the app. Why is that? Let me go to the first example. Sorry, let me go to this one. So the first time I'm running this, it takes a bit longer because it's downloading the model, right? So it takes a few seconds downloading the model, but this is only like the first time ever that you click the submit. Like if it's tomorrow or 1 week happens, goes by, and your demo is still working, if someone goes there and clicks submit, it will already be faster because the model is already loaded in memory, okay? So yeah, it's because it takes some time loading in memory. If you're using the Inference API, which I was showing you before, it can also take a bit because the Inference API, even if it's HTTP code, our servers still take a bit of time loading it. Then you ask about GPU usage. So all of these don't have GPU. All of these are using CPU, which we have by default. Usually, we have not seen that much need for GPU usage, so we can provide in a case-by-case basis the 4 GPUs. Actually, like it's the same text here. If you want it and you think that your Gradio would be faster, feel free to ping to us. So all of these are using our own computational resources, right? So yeah, so this is using a GPU hosted by us. If you want to use your own GPUs, that really depends quite a bit on how you are serving this. So that wouldn't be through Hugging Face Spaces, right? So that would probably be like in some custom hosting that you have in with your GPUs, or locally even if you have like a Jupyter notebook as well. So you could have multiple Gradio projects running in the same GPU. I don't think that's any issue at all. Actually, like Gradio is not relevant at this point. It's more about the code that is making the inference. and that also depends if the models fit in the same GPU, right? But it should work. There should not be any different thing. One last thing, actually, I also forgot to mention, which is very new. It has like very few weeks. So let's say that I would like to have this demo directly, like the short one, directly in my website, like in my own website. So right now, it was launched 2 weeks ago as well, but there's a way in which you can have like a super small JavaScript and HTML snippets, like 10 lines of HTML and JavaScript, and you can host, so you host your space in Spaces, but you can also show it in your website. So this was actually just done by Rocky AI. I think they are using like this with a very nice radio demo, in which you can record your voice, and it will give an output in another language with another text. So let's say I record myself talking in Spanish, saying, "Hey, how are you?" I can here specify French, and here I can write something completely different, and it will be able to create a new audio file with my voice, let's say, like with the same kind of voice, but saying something new. So yeah, this is something that you can also do. But yeah, going back to the GPU usage, there should not be like any specific limitation, like anything in particular compared to doing like normal inference.
Okay. How can I make the input of machine learning interface as a data crawl from web page? Is there any advice here?
How can I make the input of the ML interface as data crawl from web page? I'm not completely sure I actually understand that question. No, I'm not sure I understand that question. Sorry.
Okay, we have another question. Is it possible to save input and output, then retain the model with the later?
Yeah, yeah, that's actually a super good question, and we're actually working a bit on this. So it's not enabled right now, but what Radio allows you to do is click flag here. Right now, here it's not happening anything visible to you, but we are seeing in a way in which you can click flag here, and then you can use this again to train a model. Something that we have been playing quite a bit around. So we have this Datasets Library, which again is open source, and hosting datasets is free. So what you can do is you can save the input and the output and store directly in a dataset, and you can just keep adding those samples continuously each time anyone does click here submit, sorry, and it will generate a dataset at the end, and then you can use that dataset to train your model. So definitely this is a use case that you can already do. I think I have one example. Good example. So there is this tool called Data Measurements Tool. It allows people to input a data set, to do some kind of high-level explorations of a data set, look at high-level statistics, look at label distribution, text lengths, and things like this. And I think they have some way here to report things, which is automatically stored in these files, which is a Hugging Face dataset, which you can go later on and you can use this dataset to train a model. So definitely this is something that you can do. If you want to do it, also feel free to ping me in Twitter. I can give a bit more pointers and we can work on a bit on this together if you want.
Hello, Omar. This is me, Khulud. I have asked about the crawl question, which is
Okay.
First of all, thank you so much for the great information and presentation. Secondly, my question is now when you have just explained the data set that we can use it as input, my question is instead of data set, can I use like information directly crawled from another web page to be used as input for my model and to be shown, to be trained, and to be shown as a output after processing in my model, you know?
Mm-hmm. Yeah, so to me, this sounds a bit like a multi-step kind of thing. So definitely, like, of course, like assuming you are getting like this data correctly and with consent for getting this data, what you can have is a data set in Hugging Face spaces, in Hugging Face datasets. You can train a model if you want, and you can have that model as well in the hub, and then you would be able to create a space out of it, right? But having this directly in the space, I don't think like curling the data directly from the space, that's not something I think you could do, and I'm not even sure if I would really recommend doing something like that. I would really kind try to have like different like separation of concerns. So having your data set being hosted in a dataset repository, having your model in a model repository, and having a space that will have the demo in a space repository. I don't know if that answers your question.
Okay, so just to make sure, what you have advised is to query the data and to translate it into dataset and then use it as an input for my model, right?
Yeah,
Okay.
exactly.
Okay, great. Yeah, I got it. Thank you so much.
Thank you.
Yes, Shada, I think that concludes our question and answers session. Thank you, Omar, for this super helpful demonstration and for the informative, fun, and creative presentation. Thank you so much. Everyone, don't forget to follow us on Twitter for details about upcoming meetups. And with that, again, thank you, Omar. And thanks to everyone for joining. Hopefully we'll see you soon.
Thank you for the invitation, and thanks everyone for joining.
Thank you.
Thank you,
Cheers.
everyone. See you later. Bye.